So yeah, this is what I'm going to talk about: discriminated unions in application state. So this is the talk about Redux or Redux TypeScript, but also about Redux because it concerns application state. So yeah, discriminated unions are a term in TypeScript. But before deciphering the word discriminated, I would like to talk about unions. So how much of people there, how many people there use TypeScript? Yeah, fine. A lot of people. So you maybe you may know these terms, but still, the union is a way to combine multiple types in TypeScript. So you can have an ID property, for example, or a parameter to a function, which can contain a multiple types, and that is called a union. So here for an ID, we have a union of string or number, and this union of string and number can be saved in a type alias called ID. And in this case, we say that string and number are members of an ID type. So the problem that I'm going to talk about is the problem of overly generic interfaces. Here we have a shape interface that actually can represent a circle, a square, and a rectangle. For a rectangle, it will use width and height properties. For a square, it will use size property, and for a circle, it will use radius. And you're not sure if, for example, you get that as a function parameter, you're not sure which shape you exactly got. And another problem is that this interface allows for such tricky things as, for example, an object with a size and radius, and you cannot for sure know what shape it is. Is it a circle? Is it a square? And in that case, for convenience, you'd like to add a type property which would tell you what kind of shape it is. But another problem is that this interface allows you to have type of rectangle, but it only has radius property. So yeah, it's practically a nonsense. So here's where discriminated unions come into play. Discriminated union is let's say it's a union where members have a common property, but type of this property is a unique for each member. It doesn't make a lot of sense by just this definition. So I have some code examples which I would like to show you. Yeah. So here's the first one. Here we just deal with the shape, and here we have separate interfaces for square, rectangle, and circle. And here we clearly define that this interfaces have their size, for example, width and height, and radius, and these are required properties. And later we say that shape is a union of these three interfaces. Each of them has type property, so a common property, but type of this type property is unique for each member. So here we have square type for literal type for square, rectangle for rectangle, and circle for circle. Here we also have overly generic shape for the reference. So when we use shape, not the overly generic one, but discriminated one, in each case, and TypeScript can for sure know that in the case of square, we have size property. So we compute area in this way. In rectangle, we compute area with width and height, and in circle, we use radius. And TypeScript can allow us to use these properties because it knows that in case where we have type circle, we only have radius. And if we were to use this overly generic shape, we would get a lot of type errors because these properties are possibly undefined, and TypeScript has no idea that in case of square, you for sure have size. So here's the more real-life example where you can use discriminated unions for actions in Redux. Here we have three actions: increment, decrement, and reset, and they're constructed in the same way as in the previous example. Here we have the action union that just combines these, and counter state is just for convenience. I used counter state, so it's just a number, but it's obvious that it's state of a counter. And here is the reducer where you also use this pattern matching, and for each action you you for sure know that these have these properties on these actions. Okay, yeah, okay. So for the generic, you're not sure each of them are any, and for discriminated unions, TypeScript would give you errors if you have some problem. Hello. Yeah. Yeah. If you have a question, I think I have.
Hello. This was working. I just accidentally switched it. So who has a question?
Oh, nobody.
One question.
Oh, yeah, question.
This is going to be a hard question.
No, the question is actually going to be easy. So I've used TypeScript and Redux, and it's nice defining the actions.
Yeah.
The only problem I have, it's very verbose, because not only I have to define an action creator, but I also have to define an interface. And then I have to define the the discriminated union. Maybe there is like a magical way to reduce the boilerplate.
Yeah, there is a magical way. One magical way is just don't use action creators, because it's one of the magical ways. I will show you the second. But the magic of the first one is that you don't use action creators because you don't need to use them in TypeScript. You have all the type checking, and you can just use dispatch, and it will type check. It will type check if you give the right type, because TypeScript checks strings. But another way to just skip the action creator, just use classes, because you can, for example, define it in this way: class increment. And here you can say read only type increment. Yeah. And here will go your payload constructor. Also read only by number. So the magic of this is now you can create action in this way. Action is just new increment. And here goes your payload, 5, for example. Where do you give me error? Parameter should not be allowed. Okay. It should work. Yeah, the magic of this is that you type this only once. You don't need to now say that the return type would be something else. Yeah, that's how you can reduce boilerplate. Also, there are a lot of helper functions, helper libraries out there that can also reduce your boilerplate if you don't want to use classes. But what this example is good, it's good because you just use classes and don't use something out or something third party. You just add 0 bytes to your bundle.
I can chip in to answer.
Okay.
Basically, I think even better approach is to use action creators, but put them into one huge object and derive the interface from them automatically by using return type, and then just creating huge union type of only few creators.
Here you
per
start
method.
the holy war, because
No,
because I'm really I don't think return type and type of in this case is a good thing, because here you're defining your types by implementation. So
this is the way to go.
No, it's gonna be
let's talk later.
Yeah. It's not a discussion for a lightning talk. Yeah.
Please, no holy war in Poland. Please, I'm begging.
Yeah.
Thank you once again for your presentation. Fantastic job.